Today I will keep the presentation short, basically because I didn't have very much time to prepare it. But my expectations are to show you actually a very easy and very useful way to put a reactive approach into your applications. Basically into any kind of Java application you are working on, and you will see how easy it can be. I would start with a question: how many of you have worked or are working with Java EE APIs in the past or now or intend to? I used to be and still am actually a big Spring fan. I think Spring changed the way Java and enterprise world altogether evaluated during the years. Had anybody had the chance to work in the past with AGBs? I will try to speak louder if it's necessary. How many of you have worked in the past with AGBs? You're very lucky. It wasn't very fun. I didn't like it at all. But with the new Java EE APIs, which we have nowadays, I think in many ways they're actually even better than Spring or other frameworks. Please come in. Have you worked with or worked on developing reactive applications? Okay, that's cool. I will just make a very small intro into what a reactive application means. It's not intended to make a presentation about the reactive approach itself, but how to put it using Java EE APIs into your application. So basically, to create a reactive application, it has to be like the reactive manifesto says. It has to be responsive, message-driven, elastic, and resilient. There are some frameworks which can be used to achieve that. I think the one it's most known is Eric's Java. It's built from Netflix, and it's actually very good. But sometimes it's not suitable to use it. Why? It adds complexity to the application, and there are some customers, actually some very big players, which do not allow frameworks in their applications. They only want to go on standards. That's what I'm going to show you today, how you can achieve a fully reactive application using just Java EE APIs. Normally, how does a classic architecture look like? Every request, so let's make it simple. Let's talk about web applications. It's just simple to understand. You have a request, then you make some computations, and at the end you send back a response. Between the request was sent and the response is sent back, it can take milliseconds, seconds. If it's a heavy computation, it can take even minutes. This approach has been widely used, is still used. It's actually not a bad one. It's thread safe by definition. Everything runs in a single thread. But nowadays, where applications are much more complex, you cannot rely just on this approach. There is another problem with threads. I don't know how many of you know that. Many developers think they can create as many threads as they want. That's false. That's very, very false. Actually, on a computer, you can only run as many threads in parallel as many core processors, core power you have. So if you have 16 cores, you can run in parallel only 16 threads. That's about it. You cannot build hundreds or thousands of threads and think they will run in parallel. That will not happen. There is a thread context which actually holds these threads and runs them in parallel only. So in one time only as much threads as you have, as much cores as you have. With a reactive approach, you don't have this problem anymore because requests are not bound to a thread. Every request you make an asynchronous call, and when you get back the result, then your thread can resume actually and continue the work where it was left. You can see on this diagram how this approach looks like. So the initial request is treated by thread number 1. Then an IO call is made, a computation takes place, and then the same thread or another thread can take care of the returning result. Also, with this approach, you can do another thing. You can send actually instant feedback to the user for each step in your request processing. That's also very important. Everybody uses applications, either web-based or mobile applications, and I don't think anybody wants to wait. So like I said, it's very important to send instant feedback on every computation step. A very good example is when you load the map. If you would have to wait to make every computations to show you the map and the points you want to see, that would take minutes, many minutes. You don't want that. You want to see step by step something shown on your screen. For example, every GPS solution works this way. It couldn't actually work any other way. Also, like I said, a very important thing in this approach is that threads can be reused. You can see here that on thread number 1, the first request number 1, has not finished its call yet, but the request number 2 is working, has started his job on the same thread. That means that you will have in your application a whole less threads than without a reactive approach. That is perhaps one of the most important things you actually achieve. How can you do this with just using Java APIs? The most basic thing you can do is for your REST calls, if you use JAX REST, is in order instead to return the exact result as you do normally, you can return a completion stage, actually a completable future, which includes your response. It's just a very small change, which if you do, you achieve this asynchronous and reactive approach on your REST endpoint. So I don't know if you can see the text here, it's a little bit small. Normally you would have the response as create user, you would send the response back, and that would be, for example, turned into a JSON object. In this case, you return a completion stage containing the response, which will still be transformed in a JSON object, but you have this approach already built in. So it's a very, very small change you can do on a code level. If you want to go on a fully reactive approach, then you have to play around a little bit with completable futures. Has anybody worked with completable futures? How did you like them?
Well, yes, but here I'm wondering that even if you return, you said that you can return a completable future instead of the actual response.
Yes.
You still have the actual response, but it would be returned asynchronously. Well, you are still waiting as the client for the REST call. You are still waiting for the response. What's the difference?
So the response will take, for this example, the same amount of time. The only difference is that actually you reduce, in this case, the number of threads. But you can see with the next steps how can you improve also what you mean. So this is the very simple change you can do. We'll come back to these computable futures things, but you can take a look at this example. Basically, I tried to make an example which everybody could take it, put it in your project and use it, and just call, instead of compute, your business logic. So like you see, I don't use just computable futures anymore. I use two new annotations which are also available starting with Java 8. I don't know if you heard about them. One is called suspended, and the other one is async response. In this case, the thread actually, after it receives the request, it's really suspended, and later on it will be resumed. That's pretty cool. And in order to achieve also the performance, what I basically do, I call this, for example, divide and conquer. Let's take an example as the web application. From a web application, you do a lot of requests, basically AJAX requests. How do you do it in a regular way? You send the request and you start the computation to return the result for the request at the moment the server receives the request. But you can improve this. If you think, I don't know, what you did until now, I'm pretty much sure you will find very good examples for your own. You send an initial request. After that, you have access to a set of data. For example, you load something from the database or you upload a document. And you will know what will be the following requests. And you start the computations for all the following requests at this initial moment. And when the second, the third, the fourth, the fifth requests are triggered, they will take the result from the computable future, which was already started before. And then, because it's very logic, if you don't start your request, if you started your request before actually you generate this request, you will have a much faster response. I don't know if it's clear enough. It's a little bit confusing perhaps. If you have any questions, please. We don't have to wait until the end. I want to make also to be reactive.
What do you mean when you say you know what the following request will be?
How do you know? Exactly.
Repeat the question so that people guys can.
Oh, so I should repeat the question. Okay. So the question was, how do I know how the following request will be? I will give you an example. Like I said, you have to think about your own applications in order to find it, but I'll give you an example for a better understanding. For one application where we used this, we were uploading a document containing many informations. Basically, in this case, it was geolocation information. And I know that the following request which the browser will make is to show points on the map, to show anomalies which are in the document. And after I read the document, I start right away to prepare the results for the following request. So this actually is not just a server-side design. You have somehow to work with, I don't know, the client, or you have to not anticipate. That's not the word I'm looking for.
Like I look at this like the parallel streams for Java. So you have like independent tasks that you can write and then join and do the calculation. You know your feature request because maybe you are looping through the data, and then each of that
Yes,
bucket is a separate
true.
request which will be used in a computation, right?
That's true. Yeah, you mentioned parallel streams. Here I can give you an example. I think parallel streams are not bad. I also like them. But I can give you here a concrete example, what I saw in production. Parallel streams also create threads. If you have a list or a set with, I don't know, 10,000 entries, you can create 10,000 threads. And you have, for example, 16 cores. So they will work only 16 at a time. The problem is that, for example, some other threads which are more important, like the main thread, the main application thread, might be waiting for these 10,000 threads to finish. Of course, you can set up thread priorities, but how many of us have actually done that? I haven't, I just read about it. So you can really set thread priorities, but you normally don't do that. And that's very funny. So you use a Java 8 feature like parallel streams, and then you see that your application is running very slow because the main thread, for some reason, is waiting for a list to get processed and is blocked. That's perhaps some unexpected result, but it can happen.
Well, it should use some cached thread pool. I think internally parallel streams use an executor or something. I don't know exactly, but obviously the number of threads is limited, and there should be a thread pool that's managing these things.
It should be limited. Yeah, if it wouldn't be limited at all, it would be much worse. But even so, bad things can happen. So it's important to actually reduce the number of threads, you have.
Can I ask you as well here? Is
Sure.
this approach worth it because you add a bit of extra complexity in case of data not coming to your service? I mean, due to network issues, due to client issues, you have to invalidate all the operation you have done before.
So working with completable futures, I just make actually asynchronous request. Yes, the second future is relying on the first one.
It's relying on the data.
It's relying on the data provided from the first future. If that data doesn't come, of course, the second future cannot run. That's simple. What you are talking about actually is called resilience. What you do in these cases is to build a circuit breaker. Yeah, I think everybody knows about Hystrix.
Exactly, but I was asking if it is worth to implement such behavior. I mean, does it add extra benefits regarding the case when you have to think about circuit breakers? I mean, you have to implement the logic.
Yes, for me it adds responsiveness, and that's very important. And you can implement very easily also your own circuit breaker. For Hystrix, for example, is made on top of Java RX, yes, on top of reactive approach. So that's very easy to build on top of completable futures. A very simple mechanism which does that. I have done it, so you can build it in 2 days. So it's the same mechanism. I can make perhaps another presentation about this topic. It's pretty cool. So coming back to this code, I actually tested this code with I simulated the backend call, sorry, and I achieved this kind of results. The only thing I do, so I don't call any database, don't do any real computation. I just had a Java method with a delay of 500 milliseconds in the first example, and 2 seconds in the second example. And I made a load test with concurrent requests, and I achieved these results. And the only thing I did is actually this here. So I took my logic, I put it in a method and I call it in this block. So that's the only thing I did, and I can achieve these results. And with something which you can do in 5 minutes, I think that's quite impressive.
Did you use something like JMH for benchmarking or just?
Yes.
Okay.
So these are real results. So you can test it yourself. You should get the same results like me. Then of course, like I said, you can play a lot of around with the computable features and improve your application even further. But from my perspective, I would apply this design on almost everything because it's very easy and it only brings, from my perspective, benefits. I tried it, it worked. No, didn't use any framework. Actually, everybody would accept it because it's just Java standards. And it works on every application server you can imagine. And of course, like in a microservice way, cloud everywhere. So this code has absolutely no dependencies. Yeah, like I said, it will be short. If you have other questions?
What do you mean by suspended? The thread is not blocked, right?
The thread
It's
is.
free to do other things.
The thread will, yes, he will take care of other requests. But the computation is suspended for the request number 1. And when request number 1 actually receives some sort of event, okay, his computation finished, then he resumes. But you know, in a normal Java web application, each request for each request is actually created a new thread. That's the standard model. In this case, you don't have to create a new thread. Almost every request can work on the same thread.
But even if you're using the async response model, your final response to the client will include obviously the payload that the client waits for, right? So it's not just like a request handler, request ID that the client has to follow up on that and make a separate request to pull the results. Right?
No,
So,
no.
okay, so it's like transparent for the client. It
Exactly.
Can be anything, any application, right?
Yeah, so I would really like you to try this out. I can send you this code snippet, that's all you need. And take one functionality from application, wrap it into this code, and then make a test. And I would like to receive the results from you. You would be surprised. So,
Is it available somewhere?
I don't know, but I can send it, or I can make it available on Workplace. So all you need is really this code snippet. There's nothing more. So I think that's the easiest way to make it available on Workplace for everybody, with some explanation perhaps. So you know about it, but other people won't.
Please do share it.
Yeah, I will. Okay, then. Thank you. Sorry that I didn't have time to prepare something more complex, but I hope I achieved what I wanted to. Thank you.